In this video, we are going to discuss and solve problems about time period and frequency. So when we deal with objects in uniform circular motion, time period, which we denote with a capital T, is the amount of time it takes for the object to complete one cycle. And we measure our time period in seconds. So if you look at our diagram where we have a ball attached to a string, the time period of the ball will be the amount of time it takes for this ball to complete one revolution. Frequency, which we denote with a lowercase f, is the number of cycles the object completes in 1 second. And we measure our frequency in hertz. So if you look back at our diagram, the ball's frequency will be the number of revolutions or the number of cycles it completes in 1 second. And the reason I underlined and capitalized a lot of keywords and phrases is because a lot of students flip the definitions of time period and frequency. And I want to make sure you guys have a solid understanding of the two. And you may have noticed, time period and frequency are inversely proportional to each other. Now let's get into some problems. In this problem, we have a Ferris wheel where the cart travels counterclockwise. And we are told that the Ferris wheel's cart completes 4 cycles in 200 seconds. And we are trying to find the Ferris wheel's cart's time period and frequency. Let's solve for our time period first. Well, we know that the time period is the number of seconds it takes to complete one cycle. So we can divide seconds by cycles. And we can plug in our given values to get our time period. So we will plug in 200 seconds divided by a number of cycles, which is 4 cycles, to get that our time period is equal to 50 seconds. Now let's solve for the cart's frequency. Well, we know that the frequency is the number of cycles the cart completes in 1 second. So we can divide cycles by seconds. And there's 2 ways we can solve this. One way we can solve it is plugging in our given values. So we plug in 4 cycles divided by 200 seconds. And we will get that our frequency is 1 over 50 seconds. Or we can say hertz. Now another way we can solve this is noticing that our frequency is inversely proportional to our time period. So we can write down the formula that our frequency is equal to 1 over our time period. And we can simply just plug in our time period into this formula to get our frequency. So let's do that. So our frequency is going to equal 1 over 50 seconds, which we said was our time period. And you'll notice we get the same answer. So as a reminder, our time period tells us how much time it takes to complete one cycle. So in this problem, it takes 50 seconds for the cart to complete one cycle. And the frequency is the number of cycles the object completes in 1 second. So in this problem, our cart completes 1/50th of a cycle in 1 second. Now let's look at one more problem. In this problem, let's say we're at a carnival and we see this Target game. and we see that the target travels in a counterclockwise direction. And we are told that the target's time period is 15 seconds. And we want to find how many cycles the target completes in 55 seconds. Well, we know the time period is the number of seconds it takes to complete one cycle. So we have seconds divided by cycles. And what we can do is plug in our given values. So we know the time period is 15 seconds. So we can plug in 15 seconds equals our time, which is 55 seconds, divided by x cycles, since we don't know how many cycles the target completes in 55 seconds. Now we have to get rid of this x cycles from our denominator. So what we can do is multiply each side by x cycles. This will give us 15 seconds times x cycles equals 55 seconds. Then we can divide each side by 15 seconds so that we isolate our x cycles. And we will get that our x cycles equals 3.667. So this is saying that in 55 seconds, our target completes 3.667 cycles. Now let's look at one more problem. In this problem, we have a ball attached to a string that is traveling in the clockwise direction. And we are told that the ball's time period is 3 seconds. And we are asked, what is the ball's frequency? Well, we know that the frequency is equal to the number of cycles the object completes in 1 second. So you have cycles divided by seconds. However, unlike the last problem, we are not given the cycles nor the seconds. So how are we going to approach this problem? Well, remember, the time period and the frequency are inversely proportional to each other, and we derive the formula F equals 1 divided by our time period. So we can plug in our time period into this formula to get our frequency. So we will have F equals 1 over 3 seconds, thus giving us our frequency, which equals 1 over 3 seconds to the power of 1, or you can say hertz. So once again, this is saying that our ball completes 1/3 of its cycle per second. So in recap, when dealing with objects in uniform circular motion, time period, which we denote with a capital T, is the amount of time it takes for the object to complete one cycle or revolution. And we usually measure our time period in seconds. Frequency, which we denote with a lowercase f, is the number of cycles/revolutions completed in 1 second, and we usually measure our frequency in hertz. And don't forget, time period and frequency are inversely proportional. Thank you for watching this video and hope to see you next time.